awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So welcome back to my channel. Jika anda pertama kali hadir, selamat datang saya ucapkan. Tapi jika anda pernah hadir dan kembali semula, tahniah kerana rajin dan sudi kembali. Jadi dalam video kali ini kita akan discuss set yang ketiga dan video ini merupakan video bahagian pertama dan kita akan bincang soalan 1 hingga 10. Jom kita mula. Okay, soalan yang pertama. So the dimensions of gravitational constant G is, alright, so in order to determine the dimension of gravitational constant G, so kita tulis satu equation. So let's say we write the equation of gravitational force is equal to gravitational constant G times first mass times second mass over the distance between the two masses r squared. Okay, so daripada equation ini kita boleh carilah dimension untuk gravitational constant G. Okay, therefore we can write G. Okay, dimension for G is equal to, rearrange this equation. Okay, so you can rearrange this equation. So G is equal to dimension for force, gravitational force, times dimension of R squared over dimension of the first mass times the dimension of the second mass. Okay, and always remember the dimension for force. Ingat lagi ke? So force equation dia apa? F is equal to MA. Okay, so dimension untuk force, kalau kita dah biasa buat, kita dah hafal dah dimension of force is equal to MLT negative 2. Iaitu unit untuk force adalah kg meter per second squared. So dimension untuk force adalah capital M LT negative 2. Okay, so now we can write dimension for force is equal to, okay, MLT negative 2, and dimension of R, distance between two masses, adalah L. Okay, so kita ada squared, so L squared over dimension for the mass is M. Okay, kita ada dua sini, M besar dan M kecil. So we're gonna have dimension for both masses is M squared. Okay, so now we can cancel out. Apa yang kita boleh cancel adalah M lah. Okay, kita boleh potong ini dan ini. Therefore, okay, dimension for gravitational constant G is equal to L, kita boleh darabkan lah. So kita akan dapat L cube, okay, M negative 1, and then we're gonna have T negative 2. Okay, so this is the answer, and the answer is C. Alright, so finish question number 1. So let's proceed to the second question. Okay, so here we have a ball is thrown horizontally at 20 meter per second. Okay, perkataan horizontally, we know that the ball is projected horizontally. So maknanya kita akan ada Ux equal to apa? Tetapi Uy mesti equal to 0 meter per second. Okay, bila projected horizontally, we just have initial value of U, okay, in X direction. And then the ball is projected from the roof of a building. So let's say this is the ground. And then we have a building. Okay, and the ball is projected horizontally in this direction. So Ux is equal to 20 meter per second and Uy is equal to 0 meter per second. Okay, and then what happened to the ball? So bila dia akan jatuh ke bawah lah macam ini. Okay, so at this point we actually can calculate what is the final velocity, okay, when the ball touch the ground. So we're gonna have V, kita kena tahu Vx dan Vy. Kita ulang lagi sekali, saya pernah bagi tahu sebelum ni. Okay, Vx at any point must be equal to Ux. Tak kisahlah dekat sini ke. Okay, kita akan ada V. So Vx mesti nilainya sama dengan Ux. Nilai yang tak sama hanya Uy sahaja you kena cari. And then Vx di sini juga. Okay, gonna have V. And here is Vx equal to Ux. So kat sini pun kita akan ada Vy. Vy. Okay. Okay, so sini pun saya tersilap tulis tadi. So this one should be Vy. Okay, so Vy takkan samalah. Vy dekat sini nilainya tak sama dengan sini, tak sama dengan dekat sini. So kita kena kira, okay. Tetapi kalau kita cerita pasal Vx dan Ux, nilai dia sama. At any point, Vx is equal to Ux. Okay. So, jadi dekat sini soalan bagi tahu apa lagi? If the ball hits the ground after 4 seconds, okay, the height of the building is, so we want to determine what is h, okay, ataupun sy. It's given that the time taken, t, is equal to 4 seconds. Alright, so now let's try. In order to calculate h, okay, saya akan buat macam ni lah. H adalah sy. Berapa nilai dia? So, saya akan guna equation sy is equal to uyt minus half gt squared. So, we already know that uy is equal to 0. So, kita boleh cari sy. Okay, we can just substitute all the values given. T is equal to 4 seconds and the answer is negative 78.5 meter. Okay, so jawapannya adalah C. Okay, and then next. Okay, number 3. A vehicle on a straight downhill road accelerated uniformly from a speed of 4 meter per second to speed of 29 meter per second. Okay, over a distance of 850 meter. Alright, so when the driver brake and stop the vehicle in 28 seconds. So, calculate the distance travel, okay, during deceleration. Okay, perkataan during deceleration tu, okay, sebelum tu kalau saya suka lukis lah. So, let's say kita ada point A. So, start from point A. So, let's say U initial speed dia tadi, dia bagi 4 meter per second. And then, accelerated uniformly until 29 meter per second. Okay, let's say this is A and this is B. Okay, so kita ada VB, which is equal to 29 meter per second. Okay, and given that the distance SAB, daripada A ke B, is 850 meter. Alright, and then from B to C, okay, contoh kita ada C dekat sini. Okay, kereta itu, apa dia tulis dekat situ? The brake and then stop. Okay, the vehicle in 28 seconds. Okay, that's mean from TBC, it will stop in 28 seconds. Okay, jarak BC kita tak tahu. Tapi yang kita tahu, dekat VC, it's equal to 0. Okay, alright. And then, soalan minta kita kira lah the distance it travel during deceleration. Okay, so dekat sini at point B, okay, brake is applied. Okay, and then apa lagi? So, kita nak cari SBC. Okay, bila brake is applied at point B, so dia mengalami apa tu during deceleration. So means that kita nak SBC. Okay, so kita boleh kira lah in order to calculate SBC. So kalau you ada hafal equation S equal to half U plus V times T. So we can use this equation, okay, in order to calculate SBC. Sebab kita dah ada time. Okay, time taken to stop from B to C is 28 seconds. So kita boleh kira lah. Daripada B, so U dia adalah 29. V dia kosong. Darab 28 seconds. Okay, so the answer, okay, is equal to 406 meter. Okay. Ini cara yang paling ringkas lah. Tapi kalau you tak hafal equation half U plus VT, tak ada masalah. Kita still boleh selesaikan. Okay, saya tulis dekat sini or. Okay, we can use another method. Okay, we need to find the acceleration first. Daripada B ke C, berapa nilai deceleration dia? A dia mesti negatif lah. So, we can use equation V equal to U plus AT. Okay, so V dia stop, U is 29, plus A kita nak cari, T is 28 seconds. Therefore, A kita akan dapat negative 1.0357 meter per second. Jadi bila kita dah ada A, then we can find SBC by using equation V squared equal to U squared plus 2ASA BC. BC. Bolehlah kita cari. V is 0, U tadi 29. Deceleration of negative 1.0357 and SBC kita boleh dapat nilai dia. Which is 406 meter. Kita akan dapat jawapan yang sama. So finish question number 3. So let's proceed to question number 4. Alright, question number 4. So here we have a ball is projected from the ground with velocity of 10 meter per second at an angle of 30 degree with the horizontal. So the range of the projectile is, so let's say this is the ground and then this is the ball and it is projected at angle of 30 degree. So this is U, where U is equal to 10 meter per second. So we can resolve first UX, which is, UX duduk sebelah angle, so this is the angle. So UX is equal to 10 cos 30 degree. Tekan kalkulator, 10 cos 30 degree, you akan dapat 8.66 meter per second. And then we're going to have UY, which is equal to 10 sine 30 degree, and it is equal to 5 meter per second. And then this is the path of the ball. Lepas tu dia akan jatuh ke sini lah. Awak lukis cantik-cantik. Jadi soalan minta kita cari range, iaitu horizontal displacement. Dekat mana dia mula, so dari mana dia mula sehingga mana dia berakhir, iaitu di sini. Yang saya highlightkan dengan warna kuning ini, dan ini merupakan SX. So we already know that SX is equal to UXT. So we can use this equation in order to calculate SX. So kita dah ada nilai UX, tapi kita tak ada nilai T. So in order to calculate T, so we can find T from vertical information. So kita ada UI, so we can find T by using equation SY equal to UYT minus half GT squared. Jadi kalau kita tengok dekat sini, SY dia, bola itu launch at this point, and then dia jatuh semula ke tanah. Dia mula dekat sini, so dia jatuh dekat tanah semula. So automatically SY is equal to 0. Nilai SY tadi kita dah kira. Nilai UY tadi kita dah kira. So SY is equal to 0. UY is 5. T kita nak cari times half, 9.81 T squared. Boleh. Therefore, we can calculate T is equal to 1.019 second. So, kita bolehlah cari SX. Where UX is 8.66 times T, 1.019. Therefore, SX equal to 8.82 meter. So the answer is A. Alright, so finish question 4. So, alright, question number 5. So here we have a tennis ball, with a mass of 57 gram and velocity of 20 meter per second is struck by a racket. The ball's velocity changes to 40 meter per second in the opposite direction. So let's say this is the tennis ball and it is moving in this direction. So let's say U is equal to 20 meter per second. And then the ball will struck by a racket. So let's say we have a racket here. And what happened? The ball's velocity changes to 40 meter per second in opposite direction. So I will put negative 40 meter per second. So jangan lupa negative. So what is the average force acting on the ball if its time of contact, okay, with the record is 50 millisecond. So given that delta T is equal to 50 millisecond. Okay, so we can use equation impulse is equal to F delta T. Okay, remember this equation. So in order to calculate F, which is the average force acting on the ball, so we can write that impulse over delta T, and always remember another equation for impulse where impulse is also equal to delta P, which is the change of momentum since the ball has the change of velocity before and after struck by the racket. Okay, so we can find V and it is equal to, okay, impulse dia tadi delta P, so saya akan tulis mv minus mu over delta T. Therefore, we can substitute all the values where m is the mass of the ball, which is 57 gram, 0.057 kg, and then negative 40 V minus U, okay, over 50 times 10 power of negative 3, and finally F is equal to negative 68.4 Newton. Okay, so the average force acting on the ball, okay, is equal to 68.4 Newton. So the direction is opposite direction lah, so negative, and jawapan dia adalah D. Alright, so finish question 5. Okay, question number 6. So we have 4 kg mass moving at 3 meter per second. So let's say we have here, okay, mass A. So I will put UA is equal to 3 meter per second. And it's moving in this direction. And then it will collide with the second mass. Okay, and this mass is moving in opposite direction at 2 meter per second. So this should be UB, and it is equal to negative 2 meter per second. Okay, please remember negative. Alright, and they stick together. The combined mass has velocity of, so after collision, what happened? A and B will stick together and move with the same velocity. So soalan minta kita kira lah. Okay, so we will use the conservation of momentum, which is total momentum initial is equal to total momentum final. Okay, so initially A dengan B dua-dua pun bergerak, so dia akan ada momentum sendirilah. So MA, okay, UA plus MB UB. Okay, and it is equal to, since they are combined together, so MA plus MB darab dengan velocity V. Okay, so bila kita kira MA, mass of A is 4 times 3 plus MB adalah berapa tu? Okay, 6 kg. UB is 2. Okay, jangan lupa negatif iaitu negative 2. And here we have 4 plus 6 times V. Okay, so kalau kita nampak dekat sini, 12 plus negative 12, so kita akan dapat 0. Okay, so automatically nilai V kita akan dapat 0 meter per second. Alright, so the answer is D. Okay, so finish question number 6. Okay, so here we have a box of weight W is hung by 2 strings as shown in figure 1. So if the tension on each string is 80 Newton, what is the mass of the box? Okay, so before we start, so we need to draw the free body diagram first. So we're going to have, so this is the y-axis and this is the x-axis. Okay, so kita akan ada first kali T in this direction and another T and also W. Okay, where W is straightly downward. So angle, so since here is 140 degree, so means that ini adalah 70 degrees. So saya akan label kat sini lah. So this is 70 and another one is also 70. Okay. And then, since this object is in static equilibrium, tidak bergerak, so total Fy is equal to 0 and total Fx is equal to 0. Tapi sebab kita nak cari W, so we need total Fy equal to 0. So nak tak nak, kita kena resolve dulu Tx kita, which is here is, since T is equal to 80 Newton, so here is 80 sin 70. And Ty yang pertama yang color biru ini adalah 80 cos 70. Okay. So 80 cos 70. Alright. And then the second one sama juga, kita ada Tx dan kita perlukan Ty. So Ty pun sama jugalah 80 cos 70 yang warna hijau ini. Saya tulis kat sini lah. Okay. So in order to calculate, so since this is static equilibrium, so total Fy should be equal to 0. Boleh ya? So kita ada dua tali, so we're gonna have T1y positive because the direction is upward, plus T2y, tali yang kedua. Okay, yang biru dan yang hijau tadi, plus negative W is equal to 0. Boleh ya? Okay. And then T1y and T2y kita perlu kira lah, di mana T1y is equal to 80 cos 70. T2y pun sama juga 80 cos 70. Okay, dan kedua-dua ni nilainya adalah 27.36 Newton. Okay, so kita tuliskan dekat sini. Okay, so masukkan nilai dia dekat sini. So we're gonna have 27.36 plus 27.36 equal to mg. So soalan minta kita cari mass. Finally we can find m, where m is equal to 54.72 bahagi dengan g 9.81. So the answer m is equal to 5.6 kg. Okay, so this is the answer. So the answer is A. Alright, question number 8. So here we have 3 kg block slides down a rough inclined plane of angle 20 degree as shown in the figure, and then calculate the coefficient of frictional force. Okay, so before we start, so let's draw the x-axis and the y-axis. So let's say this is the y-axis, which is perpendicular to the surface of the plane. And then this is the x-axis parallel to the surface of the plane. Okay. And then the block will move in this direction. So this is V. Alright. So we're going to have weight. Okay. So weight must be straightly downward. So W. And the angle here must be 20 degree. Okay. And then we need to resolve W into WY, which is W cos 20 degree. And then kita akan ada WX. Okay. W sin. This one should be W sin 20 degree. Okay. And then we're going to have frictional force, opposite direction. F is equal to mu N. Dan soalan minta kita cari mu. Boleh Okay, dan jangan lupa satu lagi kita ada normal force, okay, upward. So now we want to find frictional force, okay, and always remember, tengok pada pergerakan objek adalah pada x component. So ini adalah x, so ini adalah y. Okay, since the object is moving to the left, okay, in this direction, okay, so kita terus tulislah total Fx equal to MA. Tapi soalan sebut dekat sini constant speed. So senanglah. So ini mesti kosong. Boleh ya? Okay. So sekarang kita masukkan semua force yang ada in X component. Okay. The first one adalah Wx plus negative F. Iaitu friction. Okay. So saya akan tulis dekat sini. So Wx plus negative F equal to 0. So Wx kita gantikan teruslah. Okay, W iaitu mg sin 20 degree, okay, equal to mu n. Jadi sekarang saya nak cari mu. Okay, kita ada semua nilai ni tapi kita tak ada n. Okay, the normal force. So, in order to calculate n, kita perlu guna y component. Okay, so y component. Where total Fy, so the object is not moving in y component, is equal to 0. So, in y component, kita ada dua forces. Okay, kita ada normal upward, Wy is downward. Okay, so saya akan tulis n plus negative Wy equal to 0. Therefore, n is equal to mg cos 20 degree. Okay, so kita masukkanlah nilai. N you akan dapat 27.655 Newton. Okay. So this is 655. 27.655 Newton. N Okay. So we're going to substitute N into first equation. Okay. This is our first equation. So let's substitute N into equation number 1. Okay. So, you akan dapat nilai dia berapa nanti? So, mu is equal to mg sin 20 over n. Therefore, when you substitute m, 3 times 9.81 sin 20 over n. Okay. So, you akan dapat mu is equal to 0.36. Tak ada unit ya. So, the answer is A. Okay? Alright. Next question number 9. Okay? So, here we have 1 kg block is pulled by 10 Newton force. So, kita labelkan dekat sini. Kita ada F. Okay, saya suka letak F1. So, means that we're going to have 1 external force here, 10 Newton. Okay? The coefficient of friction between the block and the surface is 0.3. So, given that this is mu, okay, and if the block is displaced 5 meter horizontally, okay, so means that it's going to move in this direction. Okay, dia akan gerak ke sini lah S dia. Kita tarik ke sini kan, 5 meter. The net work done on the block is, okay, so kalau saya lukis the free body diagram, okay, so let's say this is the free body diagram. So the first force is F in this direction. Okay, at angle of 45 degree. Dan kita akan ada frictional force. And at the same time, kita ada weight and also N. Okay, so kita boleh resolve dulu kita punya F1 kepada F1x, iaitu 10 cos 45. Kita kira lah siap-siap. 10 cos 45 is equal to 7.07 Newton. Dan satu lagi saya resolve Fy. Okay, so Fy dekat sini. Okay, boleh kira lah. Fy pun sama jugalah. 10 sin 45. Okay, Fy is equal to 10 sin 45. Tak muat tulis saya tulis sini ya. 7.07 Newton juga. Okay. Jadi, bila kita nak kira total work, okay, total ataupun the net work done on the block, okay, WT is equal to, formula dia adalah W equal to Fs cos theta. So, Ft, the total force that is same direction dengan S, cos 0. So, ini akan jadi 1. Okay. Okay, so sekarang since the total force that is same direction dengan S, sebab itu dia boleh bergerak ke kanan. So, kita kira dululah total force dia berapa. Okay, sekarang kita tengok pada kita punya free body diagram. Saya ada ini, F1x tambah negatif F. Boleh so, saya akan masukkan dekat sini. Okay, F1x plus negatif F. So, dia akan jadi negative friction times S. Okay. So, ini yang kita nak cari. So sekarang F1X kita boleh kira lah kan. Cumanya friction kita tak ada nilai friction. F1X kita dah dapat nilai dia. Tetapi friction ini kita kena kira dahulu. Tak muat ni saya tulis dekat sini. Friction is equal to mu n. So awak kena cari n, the normal force, where the normal force is equal to, ingat ya, normal force bukan equal to W. Kita ada Fy dekat sini. F1Y. So normal force kita kena kira dululah. Caranya adalah kita kira dulu total Fy. Okay, saya tulis kat sini. Total Fy equal to 0. So normal force N upward tambah dengan F1Y upward tambah dengan negative W downward. N is equal to W minus F1Y. So N, W dia kita boleh kira lah. Okay, 1 kg darab 9.81. W equal to mg minus 7.07. So normal force, you kena kira. So you akan dapat normal force is equal to 2.74 Newton. Okay, so daripada sini kita boleh kira frictional force. Boleh where frictional force is equal to mu n. Okay, so sekarang kita terus kira lah. W total is equal to F1X. F1X kita tadi 7.07 minus, okay, minus mu n. Mu is 0.3. Normal force is 2.74. Okay, darabkan dengan S. S soalan dah bagi berapa tu? 5 meter. Okay, finally W total is equal to 31.24. Saya dapat 31.24 joule. Okay, so jawapan yang paling hampir dan tepat adalah D. Boleh? Okay, kalau kata you tak nak buat terus WT. Kalau you kata boleh tak saya nak buat asing? Boleh, tak ada masalah. You cari dulu. Okay, W work by F1X. Okay. Since this is the direction, kan tadi kita ada F1, kan? So bila kita resolve, kita ada F1X in this direction. Lepas tu kita akan ada frictional force in this direction. Okay, kita tahu box tu akan bergerak ke sini, S. Jadi kalau you nak kira asing-asing, W F1X. Okay. So dia akan jadi F1X times S cos 0. You kira berapa? Contoh you dapat A lah. A joule. Lepas tu you kira pula F frictional force. Work done by the frictional force. Dia akan jadi F S cos 180 degree. Kenapa 180 degree? Sebab S ke sini. Kan? Frictional force ke sini. So 180 degree. Okay. So negative 1. So you dapatlah nilai dia negative B contohnya kan. Therefore, W total is equal to WF1X tambah W friction. Iaitu A tambah negatif B. Macam tu. So, you akan dapat jawapan yang sama lah. 31.24 lebih kurang macam tu. Okay. So, akan dapat jawapan yang sama. Tak kisah you nak buat asing-asing work tu. Nak kira asing-asing lepas tu baru total ke. Ataupun nak terus buat macam tadi pun tak ada masalah. Boleh? Okay. So, next question number 10. Okay. So, given that the spring constant K is 5 exponent 5. And then it's compressed 0.01 meter. What is the potential energy U? Half Kx squared. Senang sajalah ni. Kira saja. Okay. We just substitute the values. K squared jangan tertinggal. So, the answer is 25 joule. Okay. So, finish part 1. So, the answer is B. So, we will continue in the next video which is part 2. Alright. See you. Assalamualaikum. Dan selamat sejahtera. Bye-bye.